This is activity 1, fractions and decimals for lesson 13, 2 graphs for each relationship. And the idea behind this lesson is exactly what's in the title. For every proportional relationship, there are 2 graphs and there are 2 equations. And this first activity is just to practice working with what's called the multiplicative inverse, which you're going to see as we look at these, especially the 2 different equations. So the first problem says decide whether each equation is true or false. Be prepared to explain your reasoning. So the first problem is 3 halves of 16. So 3 halves times 16 is equal to 3 times 8. So are those equal? And so one way to look at this is just to multiply it out. So you divide 16 by 2. So this is 3 halves of 16 means to divide the 16 by this 2 right here. 16 divided by 2 is 8. So 8 is 1 half of 16. 16 is 2 halves of 16. And 3 times 8 is 24, which is 3 halves of 16. So 3 times 8 equals 24. 3 times 8 equals 24. So this equation is in fact true. Now another way to look at this is to use the multiplicative inverse. And this is what we're going to practice during this activity. So 2 times 3 halves. So I want to get rid of this 2 here in the denominator. So 2 times a half is equal to 1. So it gets rid of that denominator. So 2 times 3 halves. And if I'm going to multiply one part of this expression, and this is multiplication, it's going to change a little bit when we look at division. But when we look at multiplication, if I multiply one factor by 2, then I have to multiply the other factor by 1/2. The reason for that is that these are multiplicative inverses. So 2 times 1/2 equals 1. And that's the definition of a multiplicative inverse, is when you multiply them together, they equal 1. So I haven't changed the value of this expression at all. I've just multiplied it by 1. 2 times 1/2 is 1. And so 1 times 3 halves times 16 is 3 halves times 16. You're changing how it looks, but you're not changing the value of it. So you're keeping that balanced. And so 3 times 8, so 2 times 3 halves is 3. These 2's actually cancel out, they equal 1. So 2 times 3 halves is 3. And 1/2 of 16 is 8. So 16 divided by 2 is 8. So 3 times 8 equals 3 times 8. So we've kept that the same. In the second problem, it's 3/4 divided by 1/2 is equal to 6/4 divided by 1/4. And so the question is that true? So I'm just going to work with the left side of the equation right now. This expression that's on the left. So one side of an equation is called an expression. So I'm working with the expression on the left right now. And so 3/4 divided by 1/2 can be rewritten as 3/4, and you use the inverse operation, which is multiplication, and you use the multiplicative inverse of 1/2, which is 2. So 3/4 times 2 is the same as 3/4 divided by 1/2. Well, 3/4 times 2 is equal to 6/4. 2 times that 3 is 6, so it's equal to 6/4. That's not equal to the right side of the equation, the expression on the right side, which is 6/4 divided by 1/4. So 6/4 is not equal to 6/4 divided by 1/4. So this equation is not true. And I want to use the factor and its multiplicative inverse just for a moment and show you how that works with division. So if I rewrite the division problem as a fraction, a complex fraction, so 3/4 divided by 1/2. And you learned in earlier grades that to write equivalent fractions of any fraction, you multiply by different forms of 1, which in this case are, one case is 2/2. So that is a different form of 1. So if I'm multiplying this complex fraction by 1, I'm not changing its value. I'm changing the way it looks or the form that's written in, but I'm not changing its value. And so notice that 2/2 is 2 over 1 times 1/2. So it's 2 times its multiplicative inverse. And again, when you multiply a factor by its multiplicative inverse, by definition, it equals 1. So 2 over 2 is 2 times 1/2. So now I'm just multiplying 3/4 over 1/2 times 2 over 2, which is the same as multiplying by 1, and I'm getting an answer of 6/4, and then 2 times 1/2 is 1. So 6/4 over 1 equals 6/4. Now 3/4 divided or multiplied by 2, so what you're doing is taking this 3/4, multiplying it times 2, and dividing that by 1/2 times 2. So this 1/2 right here times this 2. So 1/2 times 2. And when you look at it as a fraction, once again, it's the same as taking the factor 2 and multiplying it by its multiplicative inverse, 1/2. So this is equal to 6/4 divided by 1. So 1/2 times 2 is equal to 1, and you get an answer of 6/4. Now 6/4 is not equal to 6/4 divided by 1/4. And I want to take one more quick look at what this means on the right side, 6/4 divided by 1/4. Well, 6/4 divided by 1/4 is the question of how many fourths are in 6/4. So if I draw 2 units and divide those 2 units up into fourths and cross out 2 of them, I now have 6/4. 1, 2, 3, 4, 5, 6. So how many fourths can I get out of these 6/4? I can get 6 of them. So that answer is 6. Now that is the same as multiplying 6/4 times its multiplicative inverse of 1/4, which is 4. So 6/4 divided by 1/4 should be equal to 6/4 times 4. So a drawing of that on the over here on the left side, 6/4 times 4. And it gets even a little bit more complicated. There's 2 ways you can look at that. You can look at it as 6/4 times the number 4. So 1/4 of 4 is 1 unit. 2/4 of 4 is 2 units. 3/4 of 4 is 3 units. 4/4 is 4 units. 5/4 of 4 is 5 units. And 6/4 of 4 is 6 units. So 6/4 times 4 equals 6. Or you can look at it as 4 times 6/4. And that's what I've drawn here. Here's 6/4, and I drew that 6/4 4 times. So then how many units can you get out of that? And you can just count them. This is 1, 2, 3, 4, 5, 6. This is a long way of saying that 6/4 divided by 1/4 equals 6, and 6/4 times the multiplicative inverse of 1/4, or 4, also equals 6. These 6 right here. Different drawing, different problem actually, but the same answer. The last problem, number 3, is back to looking at multiplication. So this is 2 8/10 times 13 equals 7/10 times 52. The question is, are those 2 sides of the equation equal to each other? So I'm going to just work again with just the expression on the left, 2 8/10 times 13. And because it's multiplication, you can multiply one factor by, in this case, 1/4, and the other factor by its multiplicative inverse, which is 4. So this is not changing the value of this expression. It is changing the look of it, but it's not changing the value because 1/4 times 4 is equal to 1. Well, 1/4 of 2 8/10 is in fact 7/10, and 4 times 13 is 52. So multiplying 2 8/10 times 13 by 1 in the form of 1/4 times 4 changes it to the same expression that's on the right side. So these 2 expressions are in fact equal, so this equation works. It is true in this case. Now, what if this was division instead of multiplication? Now, don't get confused. I'm not saying that it is division, it's equal to this part. I'm just going to use this left part and show you what happens if it's division that you're working with rather than multiplication. So if this is 13 divided by 2 8/10, I want to change the form of this. I don't want to change the value, but just the form of it. So I'm going to multiply the numerator times 4, and I'm going to multiply the denominator times 4. And that, in effect, is changing this to a multiplication problem. So I'm going to use the inverse operation, which is multiplication. So 13 times the multiplicative inverse of 2 8/10. So 13 times 1 over 2 8/10. So if you leave it as this fraction and you multiply by 4 over 4, that's the same as multiplying the numerator times 4 and then changing the form of the denominator to 1 over 2 8/10 and multiplying that by the multiplicative inverse. So 4 times 1/4. So if I rearrange these using the commutative property, this is 13 times 1 over 2 8/10 times 4 times its multiplicative inverse, which is 1/4. This becomes 4 over 4, which is the same as 1. So once again, you're multiplying the left side, 13 divided by 2 8/10, by 1. So you're going to change the value of it. If you were right here and you multiply this out, this would be 52 over 11 and 2/10. It would be an equivalent fraction. But you would change the form, but not the value. The value would still be, it's still an equivalent fraction. So the value would still be the same. But so you're multiplying by 1, so you are maintaining the value, but just not the form. So we're back to 13 over 2 8/10. I hope this makes sense. I'm just making the distinction of when you're looking at division, you're multiplying by 1 in the form of, in this case, 4 over 4, but that really is the same as multiplying by the multiplicative inverse, 4 times 1/4. So there are similarities. It takes a while to get used to it.